Yeah, good afternoon. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah, in the last class, just I was briefing you about big data, Hadoop, right? Drawbacks with the current databases and Hadoop and Spark advantages, Hadoop and Spark job market, right? So yes, Hadoop provides two services. In the yesterday session, I was briefing you, Hadoop provide two services for storage and processing. For storage, HDFS, and for processing, MapReduce or Spark. Hadoop
Sorry
is
to interrupt you, sir. Can you please brief again because I have joined these classes today. Why?
okay. So generally, yes, Hadoop is meant for two things, either for storage or for processing. For storage, we are using a file system called Hadoop distributed file system. And for processing, we are using MapReduce or Spark. Hadoop is meant for not for online applications, it is for batch applications. Two type of applications, online applications and batch applications. Hadoop is for batch applications. Online applications means user interactive applications. Here user gives the input. User gives the input, making a online transaction, booking a movie ticket. Example of this online applications. Yes. Making a online transaction, booking a movie ticket, right? Yes. Batch applications, right? User non-interactive applications. User non-interactive applications, right? Here user is nowhere required. Yes. Generating credit card statements for millions of customers, right? Here everything without user interference, right? User non-interactive applications, we call them as batch applications. Most of the financial applications and banking applications are batch applications. And what are the drawbacks with the current databases? Drawbacks with the current databases means limited storage, GBs or in TBs. In most of the databases, no parallel processing, you see. In most of the databases, no parallel processing. And if volume increases, speed decreases, right? Select total amount from sales 1. Select total amount from sales 2. Total amount from sales 3. First table has got 10 records. Second table has got 1 lakh records. Third table has got 1 crore records. Observe here 1 lakh, 1 crore, and 10 records. Which query executes faster among these three means obviously the first query, right? Because only 10 records, right? It has got total amount of 10 records. So query to query as volume increasing, speed decreasing, right? And in databases, complexity increases, speed decreases. Even if complexity increases, right? Speed decreases. Hmm. Select sum of amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1. You see total amount from sales 1, standard deviation of amount from sales 1. Yes. Means query to query, right? Average amount is a two-step process as compared with the first query. Second query takes more time. And standard deviation, lot of internal processing required as compared to the first two query. This last query takes more time. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. The major drawback of databases is handling only structure. Now coming to this Hadoop advantages, before coming to the Hadoop advantages, what? Yes, Hadoop is Hadoop. Hadoop doesn't follow client server architecture. It's not for client server, right? Hadoop follows master slave architecture.
So difference between both.
Which one? Client server and master slave.
Yes, sir.
Client server means when clients gives the clients gives the request, server gives the response. Like it's like online for online applications, right? Whenever request giving response, but here this is not like online applications, right? Master slave architecture. Just observe this example, right? Single master and multiple slaves, we say. Single master and multiple slaves. Slave 1, slave 2, slave n. These are slave nodes. This is master node or name node. Master node or name node. Okay. Here slave nodes are data nodes, we say. If there is a file f1.txt, here each system capacity 1 TB, 1 TB, 1 TB, right? This file is divided into smaller parts in Hadoop. Always data is divided into smaller parts. This f1.txt, assume it is 2 TB. This 2 TB cannot fit into any of this system. So it is divided into smaller parts and distributed across multiple systems. Here the two advantages we see. Data distributed across multiple systems and data processed by multiple systems parallelly. So two things, what are that? Parallel processing and distributed storage. Means any bigger file also can be accommodated within this, right? And any bigger file can be processed at very quick time. Yes. So here master nodes assigns the task to the slaves, like T1 task to S1, T2 task to S2, T3 task to S3. Three tasks will be executed parallelly by the three slaves parallelly. Master node responsibility. Assigning task. Load balancing means that the tasks or the load should be balanced equally to all the slaves. Fault tolerance. Fault tolerance means yes. When multiple systems are running parallelly executing multiple tasks, suddenly if any one system goes down, then the task of it will be assigned to any of the other slave. That process we call fault tolerance. Health monitoring, right? Health monitoring. Before assigning tasks to the slaves, first the master node will have the entire information of the health status of each and every slave. Slave node responsibilities are two: storing the data and processing data. Now, Hadoop advantages. Advantages of Hadoop, right? Unlimited data storage is possible. Unlimited data storage is possible, right? Horizontally, unlimited number of slaves can be added. Very high speed processing because of parallel processing. Can handle all varieties of data. Can handle all varieties of data like structured data, unstructured and semi-structured data. Open source, no licensing required. It's a open source, no licensing required. Commodity hardware means Hadoop can run on any hardware systems, right? It doesn't mean that you need to have highly configured systems. It can run on any hardware. Open source, no licensing required. Most of these Hadoop and Spark products are from Apache Mirror site. You can download and you can install these things. If you see the speed of various databases, right? Yahoo has performed a test to check the speed of various databases. Yahoo has taken a table of 100 TB consisting of 1024 columns, task sorting based on 16 columns. Sorting based on 16 columns. Time taken, right? What is the time taken? Oracle has taken nearly 3.5 days to process this 100 TB data, sorting based on 16 columns. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netezza has taken 3 hours. But Hadoop has taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. You will ask why databases like Oracle doesn't support unlimited storage like Hadoop. For databases, there is a limitation, right? Means even for these databases like Oracle, MySQL in real time, can go with max. We can go with multiple systems. We have got slaves. Like Oracle can go max of 256 systems or 256 slaves or CPUs. MySQL can go with max of 54, right? MySQL Express can go with the maximum 256. DB2 with 256. SQL Server with 256. Teradata 512. Netezza also 512. Vertica also 512, right? But the latest Teradata and Netezza, they're supporting 1024 slaves. There is no limit on the number of slaves that Hadoop can have, right? It can go with unlimited number of slaves. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, Facebook going with 42,000 slaves. So what are the Hadoop ecosystem components that I'll be discussing as part of this course? Like storage and processing components, right? Like HDFS for storage, MapReduce for processing. Yes. HDFS for storage, MapReduce for processing, Apache Hive, right? Yes. Apache Hive, it's a kind of data warehouse kind of environment within the Hadoop framework. We use a language called HQL, Hive query language, which is similar to SQL. Scoop for importing data from databases to Hadoop and exporting data from Hadoop to databases. That is SQL plus Hadoop, the first two characters of S and last three characters of it, right? For importing and exporting. NoSQL, schemaless behavior, random access. HBase, and NoSQL database, right? Not only SQL, right? So SQL databases, NoSQL databases, right? NoSQL database, that doesn't have any schema. Record to record, any number of fields can be maintained. First record with 3 fields, second record with 5 fields, third record with 10 fields, right? Record to record, any number of fields can be maintained. Random access. Yarn, yet another resource negotiator, right? Zookeeper, controls and coordinates all the Hadoop components. And also I provide you knowledge on this streaming technologies like Flume Kafka, like streaming technologies, right? Streaming data means data which keeps on incrementing, data which keeps on generating, data which keeps on generating, which keeps on incrementing. Such data we call it as streaming data. And finally, the major portion, right? Major part I'll be discussing about the Spark core programming, Spark SQL programming, Spark streaming, right? PySpark core, PySpark SQL, and PySpark streaming, all this. Okay, this is what will be discussed as part of this course, right? Yes. And now I'll be just discussing, right? Before I go with, right, how exactly the data storage and processing is happening. Before that, I'll just give a small introduction to this PySpark, right, which has got great boom today. Spark with Python implementation. Right. Just observe this PySpark, right? Apache Spark, why PySpark, need for PySpark. And PySpark, we can also implement using Scala language, using Python language, which is mostly preferred. PySpark features, real-time usage, and its job market, right? Okay. So what is Apache Spark? Apache Spark, right? Yes. It is an open source cluster computing, that is distributed cluster computing framework, which was introduced by Apache Software Foundation. It is a it is for their big data analysis, processing, and for computation. Why PySpark? Why PySpark? See, PySpark is the Python API to use a Spark. It is an open source, right? I said cluster computer used for big data solution. And this PySpark is a lightning fast technology, right? That is designed for fast computation. It is a very demanding tool among the data engineers, right? For working with bigger data sets, right? Generally, this PySpark we use for running, creating data pipelines, ingesting data into the databases, running machine learning algorithms, working with the graphs or data streams, and many more, right? And need for PySpark means if you see like huge amount of data is getting generated, so the huge amount of data which is generated will have hidden patterns, market trends, unknown corrections, customer preferences, other useful business informations, right? So we need to extract that valuable information from this raw data, right? So we require some efficient tools to perform these types of operations on the huge data. So already we have got tools available. We have got various tools to perform these operations, right? But we need to have some scalable and flexible tools to crack this big data and gaining benefit from it. So PySpark is such a kind, right? Yes. See, both Python and Scala are mostly used. Spark with Scala, Spark with Python. Both languages are mostly preferred. Okay. Today, like Python, it has got a bigger community, right? It has got it's open source and has got huge community. Python, right? And Python is dynamic typed as compared with Scala, it is static type. And various features we see in PySpark that I'll be discussing later, like real life usage of PySpark, various usage. The main feature of PySpark, two main features I can say: in-memory computation within the memory level storage, within the memory level processing, in-memory computation. Secondly, it's lazy evolution. PySpark is lazy evoluted, means on-demand executing, right? When on-demand executing, lazy evoluted. Whenever on-demand only executing it.
Means can you explain in real time scenario with the load?
Which one?
This PySpark features fifth one.
So PySpark in this will be mainly discussing with RTDs, data frames and data streams. In Spark core we see RTDs, in Spark SQL we see data frames, and in Spark streaming we say DSS streams. So it is a data. I said lazy evolution, right? Lazy evolution is nothing but just like a normal function. Function, if you call only, it executes. Difference between PySpark versus Python versus, okay, very simple, right? See, 1 second, I'll come back to it. So Spark, there's a Spark, very high speed processing technology, right? Very high speed processing, huge data processed at quick time. So the Spark is an execution model implemented using multiple languages. It is implemented by using Python language, implemented by using Scala language, implemented using Java, implemented using our language. Multi-language support. These two are never used at all. Java and this Python and Scala are mostly preferred for implementing Spark. Means the language coding, programming goes in this Python or Scala. Previously Scala was used, now Python is mostly preferred because of this ML techniques. Python has got powerful libraries, like thousands of modules. It has got huge community, right? So Spark with Python implementation we call like PySpark. Spark implemented using Scala. Scala is an extensible language. It is extension to Java language, right? So Python provides multi-language support, like Python has got procedural-oriented features, object-oriented features, scripting features, and modular programming features. Okay, so today in the industry, right? Python language and Scala language are mostly preferred for Spark environment. Yes. And in real life use case, right, where this PySpark is preferred, where this PySpark, right, is in commercial sector, right, it is for real-time processing. Banks and other financials, they use Spark to retrieve the customer's profile and they're analyzing, gain useful insights. And for credit risk assessments, yes. And in healthcare, real life usage of PySpark means in healthcare for analyzing the patient's records along with their previous medical reports. And entertainment industry, in the entertainment industry, right? The popular OTT platform Netflix using this PySpark, right? Yes. Spark for real-time processing and for personalized online movies, right? So nearly 450 billion events per day that are streamed over the server-side application, right? And for trades and e-commerce. So leading e-commerce sites like Flipkart, Amazon, all this they use Spark for advertising and also for recommendations, right? People who like this product may also like this product. This kind of recommendations also can be provided. And for tourism industry also, right? For comparing different tourism sites and advising the customers, right? Yes. Yes. So most of this 60 to 70% of our course time will be spending on this PySpark only, right? Which has got a great boom. People who has got knowledge on this PySpark, who has got command on this PySpark, right? You see the packages, right? Huge packages, right? 1.5 times more than the other technology. Okay. There is just a small introduction, but later I will be briefing you about this PySpark. A lot of discussion on it. How exactly the data is stored in Hadoop? How exactly the data is stored in Hadoop? In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is subdivided into blocks. Each file is subdivided into blocks. Default block size 64 MB. In latest version, default block size is 128 MB. If you 200 MB, right? Assume it's a telecom data. That's got telecom data, right? So this file of 200 MB, it is divided into blocks. Default block size, assume it is 64 MB. Into how many blocks the file is divided? Means file size by default block size. 200 by 64 means 4 blocks. First block of 64 MB, second block of 64 MB, third block of 64 MB. And fourth block, you see, only 8 MB, right? 64, 64, 64, 192. And the last one, 8 MB, only 56 MB free in that. Next, I will f2.txt, 192 MB. It has got a banking data. Number of blocks. Number of blocks means block size, file size by default block size. File size by default block size. 192 by 64. Exactly 3 blocks, right? 3 blocks means B5, B6, B7. 64, 64, 64. Observe, in Hadoop, any file, it will be divided into smaller parts we call like blocks. In the first example, it is divided into 4 blocks. The last block, 8 MB only utilized, 56 MB is free. Why second file f2.txt data is not stored in B4? Why f2.txt data is not stored in B4 when it has got 56 MB free? Assume why B5 data is not stored in B4 when 56 MB is free means I am retrieving F1 first file, f1.txt means it has got B1, B2, B3 and B4. If B5 data is stored in B4, means whenever you're retrieving f1.txt, 64 MB of B1, 64 MB of B2, 64 MB of B3. But if you come to this, assume if 56 MB of f2.txt is stored, the total file size will be 256 MB, but the actual file size is 200 MB, which is a wrong computation. when we are retrieving telecom data, here we are getting a pot of banking data. We can also keep our own block size. We want to divide the file into my own block size like 50 MB or 100 MB also. I can set my own, I can configure my own default block size. So here, yes. Design principles with respect to HDFS blocks, right? Every file will have dedicated number of blocks. In each block, no two files data to be stored. All the blocks will have equal volume except the last block. Yes, all the blocks will have equal volume except the last block, means last block has got only 8 MB, right? 8 MB data only free, right? Okay, understood, right? Here, if B5 data is stored in B4, whenever I'm retrieving f1.txt, the 4 blocks of f1.txt, it will be retrieved. Along if the second file data is stored in B4, whenever you're retrieving, you will get 256 MB, but actual file size is 200 MB, means which is wrong computation, means. So design principles you need to follow here is, in a single block, no two files data to be stored. Every file will have dedicated number of blocks. Every file will have dedicated number of blocks. Okay, fine. Just now I said we can also configure increase or decrease the block size. Increase or decrease the block size. Yes, go to the Hadoop installed folder. In that we see conf one XML file, we see it's an empty file. So if you open that file and just write these 4 lines. If you want my own block size, property, close the property. Name dfs.block size.
In this XML, how much we can keep maximum?
What is it? Block size?
Yeah, block sizes.
Okay.
Is
I'm
it in
coming.
GBs?
So okay, what? Just 1 second. Answer. dfs.block size. Here I have given 50 MB. By default, it is 64, 128. You can give 200 or 300 or 50 or 40 or 200 or 300, 400, right? Any block size you can keep. So which is advantageous, having block size, smaller block size or bigger small? If I give 500 MB as the block size, is it advantageous or giving 10 MB or 5 MB as the block size? Which is advantageous, having bigger default block size or smaller? Assume I got a file of 900 MB. Default block size, I'm setting it as 500 MB. I'm configuring default block size 500 MB. Is it advantageous means? Just observe. You only say whether it is advantageous or not. Into how many blocks this file will be divided? If it is 500 MB means 2 blocks. B1 with 500 MB, B2 block with 400 MB. B1 stored in S1, B2 in S2. Assume you got 40 node cluster. Assume you got 40 node cluster where you are using only 2 slaves in it. You have got 40 node cluster where you are using only 2 slaves. Even though you got 40 systems, still you are using only 2 systems, right? Instead, if the default block size, if it was 64 MB, nearly 15 slaves will be the, if it was 64 MB, data should have been stored across 15 slaves at least. Means 15 slaves or 15 systems are running parallel. Here, work done by 2 persons, work done by 15 persons, there will be a different speed, right? We have got differences between the speed. Work done by 2 systems and work done by 15 systems, right? So if it was 64 MB, it should have spread across multiple systems. As you kept 500 MB, only in 2 systems only, it stored 900 MB file. So it's a drawback that even though you got 40 systems, you are using only 2 systems for processing a file. Yes. Assume, what if we take less block size? File size is 50 MB. Default block size 5 MB. Just I kept to 5 MB. 5 MB means stored across 10 systems and processed parallelly. Means here advantages or drawback means a small file again divided into smaller parts and computed and the output is collected. It's a time taking process, but already it's a small file. Okay. A small file divided into smaller parts and distributed across multiple systems. And again, computing that output and collecting the output, right? It's a time taking process. So both are not advantages. Very big file, speed decreases. It is a very small block size, right? Should be distributed across multiple systems, again retrieving them. It's a time taking process. Now, I'll be discussing 4 cases about this, how exactly data storage and processing happening, right? In the Hadoop, right? Case 1, in the Hadoop, the file is divided into blocks. Number of blocks, if it is equal to number of systems. We see full parallelism. We see very high speed. Assume you got 3 blocks, 3 systems, S1, S2, S3. 3 blocks means, sorry, B1, B2, B3. Slaves, S1, S2, S3. Assume you got a file f1.txt, the size, assume it's a 192 MB file. Into how many blocks it is divided. Default block size, assume it is 64 MB. Number of blocks, how many blocks? 192 by 64. 3 blocks. B1, B2, and B3. Assume in B1 10 lakh records, in B2 10 lakh records, in B3 also 10 lakh. How these blocks are stored across this cluster? Master and slave. Slave 1, slave 2, slave 3. B1 block stored here, B2 block stored here, B3 block stored here. This is the master node or name node. Name node stores the metadata information. Data about metadata means data about data. Here observe f1.txt is divided into how many blocks? B1, B2, B3. The three blocks stored in S1, in S2, and S3. And stored here B2, B3. B1 10 lakh records, B2 lakh records, B3 10 lakh records. If the data is sensitive data like banking data, it's a huge loss. Okay, I'll come back to this fault tolerance model, but how data is stored, right? B1, B2, B3 in S1, S2, S3. Data processing. Next is what? Data processing. Your job is to process f1.txt. Always it will be divided into tasks. Number of tasks always in Hadoop depends on number of unique blocks. Number of unique blocks. Number of tasks, number of unique blocks are 3. 3 means 3 tasks, T1, T2, and T3. Now, job to process f1.txt divided into S. T1, T2, and T3 tasks. T1 for executing, right? T2 for executing, B2. Try to respond. I want the sessions to be interactive, right? Everyone try to respond. T3 task is for what? Unmute yourself and try to keep responding. B3. B1 10 lakh. T2 is for B2 10 lakh. Yes. Who should execute this T1 task? Which system or slave has to execute this T1 task? Everyone.
Yes, one.
Yes, one.
S1 only, right? There is no other choice because S2, S3 cannot execute the T1 task because B1 block is present. B1 block is present, right? In S1, S1 only should execute. Who should execute T2 task?
S2.
S2 only, right? There is no other choice because B2 block is present in S2, S2 only should execute. T3 task should be executed by S3. There is 3 blocks B1, B2, B3 are executed by 3 slaves S1, S2, S3 parallelly. You can see full parallelism. No task is in waiting. 3 blocks means 3 tasks. 3 tasks T1, T2, T3. 3 tasks are executed by 3 slaves parallelly. That's why we see high speed. How this data is distributed, how they are stored across multiple systems, and how they are processed. We don't need to perform all this. Everything happens in the automated fashion. So just we need to give that block size. That's enough. Now, case 2 you observe and try to respond. if the number of blocks greater than number of slaves. Four blocks, but only two slaves. Two slaves, S1 and S2. You got a file f1.txt, 230 MB. Default block size assume 64 MB. Into how many blocks?
Four blocks.
Four blocks, right? B1, B2, B3, B4. These four blocks, how they are stored in the cluster, master and slave. Only two systems, right? Assume two systems. S1, S2. B1 here, B2 here. Again, B3 here, B4 here. Master node or name node? Yes. Stores metadata information f1.txt divided into B1 by S1, B2 stored in S2, B3 stored in S1, again B4 in S2. Now, series data processing, right? Data processing. Always job to process f1.txt always will be divided into blocks. So, in a job always divided into tasks. Number of tasks equal to number of unique blocks. I'll say why I'm using the word unique. Unique blocks. How many blocks here? How many unique blocks here? Yes, try to answer.
Four.
Four unique blocks means how many tasks? Four
Four
tasks.
tasks.
Job to process f1.txt. T1, T2, T3, T4. For executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. Who should execute the T1 task? There is B1.
That's one slave mission.
Who should execute the T2 task?
S2.
B3, that is T3.
This one.
S1 only again.
Yes.
T4, S2. Means if you observe carefully here, S1 and S2. S1 executing two tasks, T1 and T3. S2 executing T2 and T4. Assume in S1, T1 is executing, T3 will be waiting. In S2, T2 is executing, T3, T4 will be waiting. Once this T1, T2 execution finished, next T3 and T4 execution will start. Means here when T1, T2 are executing, two tasks, T3 and T4 are in the waiting state, right? Yes, that's why I said lesser speed here. Lesser speed. In the previous case, more speed. Now, observe this case 3. More blocks, but only one slave. No parallel processing at all. 4 blocks means B1, B2, B3, B4. Only one slave. Assume the file size 240 MB. Default block size 64. 4 blocks B1, B2, B3, B4. B1, B2, B3, B4 stored in S1 only. All these 4 blocks are stored in S1 only in a single system. Who should process all these 4 blocks?
S1 only.
All these 4 blocks are T1 executed by S1, T2 also by S1, T3 also by S1, T4 also by S1. So all these
So
4
here T1, T2, T3 means like F1
tasks,
files is divided into 4 parts, no?
4 blocks. Executing the block 1 is nothing but T1 task. Executing the B2 block is nothing but task 2. Here 4 tasks are executed by only one slave. Okay. So here no parallel processing at all. Sequentially they are executed one after the other. Yes. In the case 1, if you have got 4 tasks executed by the 4 slaves, assume each task takes 1 hour. To complete all the 4 tasks, total time taken 1 hour only. 4 tasks are executed by 4 slaves parallel. Okay. In case 2, 4 tasks, but only 2 slaves. Each one taking 1 hour to execute. Total time taken means 2 hours. Means in the first round only T1 and T3 only will be executed. In second round T2 and T4 also execute. Total time 2 hours. The third one, 4 tasks, each task takes 1 hour. Total time taken, right? Total time taken is what? 4 hours. Observe this case 1 once. T1 task executed by S1, T2 task by S2, T3 task by S3. Suddenly, if any system is down, when 3 tasks are executed by the 3 slaves, 3 systems S1, S2, S3, suddenly if any system goes down, S2 system goes down, then 10 lakh records, 10 lakh records of B2 are lost. This data is lost and T2 task is failed. How Hadoop is able to overcome this kind of situation, right? So there is a concept called replication and fault tolerance. If data is sensitive data, yes. If the slave is down, if data is lost and the task is failed. So we have got concept called replication and fault tolerance. Replication and fault tolerance. Replication is nothing but duplication. Default number of replicas in Hadoop was 3. We can also configure increase or decrease the replications.
If task 2 is got failed, that means like we need to reprocess it, right? Again, we need to initiate the task 2.
Observe
Isn't
here.
it?
Okay, here observe. F1.txt is there. 192 MB. Number of blocks 192 by 64. 3 blocks. Which are the 3 blocks? B1, B2, and B3. B1 by 3 times, B2 by 3 times, B3 also by 3 times. B1 by 3 times, B2 by 3 times, B3 by 3 times, totally 9 blocks. How these 9 blocks are distributed, right? This is your master. These are your slaves, 3 slaves. S1, S2, and S3. B1 here, B2 here, B3 here. Again, B1 here, B2 here, B3 here. Again, third time, B3 here, B1 here, B2 here. 9 blocks you got. 9 blocks are distributed across the slips. F1.txt divided into 3 blocks. Where B1 stored in S1, also in S2 and S3. B2 also stored in S1, S2 or S3. Means this B1 block is stored across the 3 systems. B2 also stored across 3 systems. B3 also stored across 3 systems. Data processing. Data processing, right? Yes. Job is to process f1.txt. Number of tasks always depends on unique blocks. Now try to say how many unique blocks here. 9 blocks or 3 blocks?
3 blocks.
3 blocks only. That's why I'm using that unique T1, T2, and T3. Job to process f1.txt. T1 is for executing B1. Who should execute this T1 task? S1. S2 also can, S3 also can execute any of this S1, S2, S3. Or because B1 is present in S1, B1 is present in S2, B1 is present in S3. Anybody can access it. B2 also. Who should execute this means S1, S2, and S3. S1, S2, and S3. Who should execute T1 task means assume it has selected S1 only. Who should execute T2 task means assume it has selected S2 only. Who should execute T3 means it has selected S3 only. So T1 by S1, T2 by S2, T3 by S3. Suddenly, if any of the system goes down, do you think S2 is for executing T2, T2 is for executing B2? Still that B2 is present in S1 or S3, right? In S2, mainly the T2 task is executing for B2. That B2 is present in other systems or not? So do you see any data loss if the system goes down? Still B1, B2, B3 available in S1, B2, B2, B3 available in S3. There is no data loss. Task, T2 task will be assigned to either T1 or T3. T2 task will be assigned to. Okay. So there is no task failure, right? There is no thanks. So there is no task failure here. This T2 task will be assigned to S1 or S3 because they also got B2 block. They will be executing. And there is no data loss also, right? But here, two things you need to understand. If this particular S2 is down, this T2 task will be assigned to whom? S1 or S3? That is one. If T1 task can be executed by S1, S2, S3, why you are given preference to S1, why not to S2, S3? What is the criteria followed here, right? In assigning a task to a slave. Observe this, right? What is the criteria followed in assigning a task to the slave? So totally 4 steps criteria right here. S1 executed by T1, S2 is executing T2, S3 is executing T3. T2 is down and then T2. If S2 is down, T2. Then T2 should be executed by S1 or S3. Then T2 has to be executed by S1, S3. What is the criteria means? Here, what is the steps followed in assigning a task to the slave means? Master node selects the slave which is highly configured. If they have got both same configuration, it selects the slave which is highly configured. That is, which has high hardware configuration. Both are equally configured. Then master node selects the slave which is more ideal among these two. Among S1 and S3, which are more ideal, more free. If both the slaves are free, then the master node selects the slave which is nearest to it. If both are equally near, if both the slaves are equally near, master node selects the slave which is nearest to it. Means nearest to it means master can be in one country, slave can be in another country. Master can be in one state, slave can be in different state. Master in one city and slaves in same cities or different cities. And everything within the same lab, if things all are equally near, master node selects the slave which has good health status. Now and then, if you have got any hardware and software problems in anyone, if both of them are have got good health also, right? Then master node selects any one slave randomly. What do you mean by fault tolerance means? If totally if anyone slave goes down, will be assigned to available slaves. This process is called fault tolerance. The task T2 will be assigned to available. Then the process is called as fault tolerance, right? Yes, we can also configure or increase or decrease the replications. We can also configure increasing. If it is too sensitive, we can keep more replications. how to configure the block size and replications, right? Same thing. The same file, right? HDFS-soy.xml, two properties we need to configure. First property for block size, property and name and value. Name is dfs.block size 50 MB. One more property, opening and closing. dfs.replication. By default 3, you can keep 4.
Is it suggestible for two, the replication count?
Depending upon the sensitivity of your data, right? If you want more replications, yes. If you've got very sensitive, like, okay, you can keep 4 or 5. If otherwise, you can keep 2. Okay, 1 second. Okay, fine. So understood, right? How exactly the data storage and processing is happening? What do you mean by replications or fault tolerance? How to configure the block size and replications? Oh, okay. And see, this is the course content I'll be discussing, right, in brief. Yes. Hadoop HDFS, right? Hadoop distributed file system, map reduce, scoop importer export operations, yarn yet another resource negotiator, NoSQL database, not only SQL, right? And HBase, one NoSQL database in brief, and Hive, more discussion on Hive, right? It's a very important component of Hadoop used in every project. See, creating Hive tables, internal, external tables, working with XML data, JSON data, URL weblog data, UDF, UDAF, UDTF, right? Yes. Partition table, non-partition, multi-column partitioning, dynamic partitioning, bucketing, indexing, right? All this. And coming to this PySpark, right? Introduction to PySpark session, Spark context, repartitioning, broadcast variables, PySpark RTD computations, persistence options, PySpark core computation, fault tolerance model, grouping segregations, various actions and transformations with working examples, PySpark SQL data frames, or select collect with column, many built-in functionalities, and PySpark SQL functions, and PySpark built-in functions with many working examples, right? All this PySpark external sources and deployment modes, PySpark applications, trace and task drivers and executors, and PySpark streaming and integration with Kafka. So I said, so here it will be Hadoop is going to be discussed. Spark with Python, like PySpark in brief. Linux, that is how much required for this will be discussed. And Python, right? Python nearly like 60 sessions on this Python, right? Nearly 60 to 70 sessions on this. So this entire thing, the fee structure is 15K. If you already know Python and if you doesn't want Python, right? Only Hadoop, it's like the fee structure is 12K. And if you see the Python course content, right? It will be nearly to 60 to 70 sessions. Python basics, Python operations, modes, executions, variables, constants, type conversions, operators, IDs, different IDs, working with different IDs like Anaconda distributions, Jupyter, Spider, Eclipse, NetBeans, flow control statements, looping statements, strings in Python, collections, Python lists, Python tuples, sets, dictionaries, functions, modules, packages, errors and exceptions, file handling, object-oriented programming concepts, regular expressions, database connectivity, Python data and time, OS model, advanced concepts, graphical programming, Excel workbook, data analytics, introduction to data science, Python pandas module, NumPy module, and matplotlib module in brief. So for these 30 topics in brief, right, for Python. So you can attend for Python, you can attend any of my weekday batch. Monday to Friday, you can attend any of my weekday batch. So on this coming Friday at 8 a.m., there is a batch starting, right? Friday means Feb 6th, Feb 16th. And same on Friday at 7 p.m., right? Evening. One batch starting, right? On this, if you want to attend. Not only this, any other timing, multiple Python batches will be running, right? Later, if you're based upon your timing slots, you can also change the timings if any other batch starts. Right? This will be let me make it clear. For next week also, it will be at 1 p.m. only. It starts at 1 p.m. But after that, next week only. But I'll make it clear. The timing of this batch will be 4:30 p.m. right? To 6:30 p.m. on both Saturday and Sunday. Because it's 1 p.m. means it's like for the US people from US are unable to attend the session. It's like midnight to 3 o'clock, 2:30 or 3 p.m. Midnight 3 o'clock for them, right? So it was moved to 4:30 to 6:30, the timing for this. Okay, not next week, it will be at 1 p.m. So everyone need to get enrolled. Next Saturday, the link is changing, right? The link will be changing. You need to get enrolled. The new link will be forwarded to your mail ID, right? You can see the payment details, other things in the chart panel. You see in the chart, all the details, contact details, yesterday's session video, right? Yesterday, if anyone not attended, right, you can go to that video link. The course content is forwarded, the video link is forwarded, the contact details are forwarded, right? Payment details. Whenever you do the payment, don't forget to share the screenshot of your payment to this online team. There is DURGASOFT online training at gmail.com. Any queries from your side, anyone? Yes. Okay. Any queries? Okay, so this next week we'll be discussing more on this. Hadoop architecture I'll be discussing and followed by the practical part. Yes. So yes, I'm stopping for now. We'll continue in the next Saturday at 1 p.m. right?